Alright, Pre-Calc Chapter 6, we're going to look at Case 2 today. So remember, we're talking about law of sines and cosines. Case 2 is going to be about the law of sines still, and we also call this the ambiguous case. And remember the ambiguous case because your solutions could involve 0 triangles, 1 triangle, or 2 triangles. Okay, so we could have multiple solutions. We'll talk about each one. Now, the ambiguous case, like I just said, it's 2 sides and the non-included angle. So that non-included angle is very important. And like we said, it will have 0, 1, or 2 triangles. Looking at an example here, then if we talk about these 2 sides, the angles it would create, side-side angle, would be anything except 3, because 3 is in between those 2 sides. So we could say that angle 1 or angle 2 would create side-side angle. Okay, so either one of those. Now, the easiest way to find out if there are 2 triangles, there's a bunch of formulas we can go through and you can memorize them, you can apply them, but it's not really needed. If you just think logically about how we do this, actually try to find 2 triangles. If there are 0 triangles, you won't be able to find any real answers. Meaning, when you do sine inverse, your value would be above 1 or below -1, which remember you would get in a non-existent value, an undefined value in your calculator. If there are 2 triangles, you'll actually be able to get 2 triangles. And if there is 1 triangle, if you can't find 2 but there are 1, you wouldn't be able to find 2 because an angle that you're looking for would be negative. So that third last angle would give you a negative value, but you would have gotten a positive value in your first triangle. We'll look at an example of that in a minute. So the first triangle that you find, as long as it exists, shouldn't be difficult. We're going to do that the same way that we did the law of sines. Okay, now here's an example of why we would get 0 triangles. So we've got our 2 sides, and the way our angle is shaped, there's no way that we could turn this side and ever create 1 triangle, or 2 for that matter. We would get 2 triangles because this undetermined side here on the bottom could be 2 different lengths, and this angle up here could be 2 different angles, which means having one side of 54 could turn 2 different ways. And no matter where we put these 2 sides or have these 2 lengths, nothing else in the triangle differs. So we could have 0, 1, or 2. So an example of that then, we're going to use law of sines again. So you see we have things labeled here. We have that A is 81. We know that B is 62. So we don't know C1 or C2, and we know that alpha is 43 degrees. So we're going to apply the law of sines. First thing we're going to need to find, since we have B and not beta, but we have A and alpha, if we apply the law of sines, so say sine of 43 over 81, that's alpha over A, equals the sine of beta over B, that's 62. And so the sine of beta, when we plug this into our calculator, would just be 62 times the sine of 43 over 81. And that means that beta is going to give us a value of 31.5 degrees. And then what we can do, and remember to find beta here, you'd have to do sine inverse after you did all that. So sine inverse. After we found beta, we could do 180 minus 43 minus 31.5. That will give us gamma 1, or C1, whichever you want to call it. And that's going to be 105.5. And then applying the law of sines, so we're going to apply the law of sines, we could say sine of 43 over 81 equals the sine of 105.5 over C sub 1. That would give us a C sub 1 of 114.4, which makes sense again because our smallest angle opposite our small side, biggest angle opposite our biggest side. Now, to try to test to see if we have a second angle, since we found beta 1 first here, we're going to find beta 2. Okay, and beta 2 is always equal to 180 minus the first beta that you found. So if we do that 180 minus 31.5, we are going to get 148.5. And then we can find gamma 2 the same way, doing 180 minus 43, because alpha doesn't change, 180 minus 43 minus 148.5, and we're going to get negative 11.5 degrees. Which, if we're talking about the unit circle, sure, that makes sense, but when we're talking about triangles, a negative value doesn't work. So you see, there's no point in finding C2. We went through all of this. We got an illogical number, a negative angle, which we can't have. And so that tells us that there is 1 triangle solution here. Okay, and these are the values of that one triangle solution. Okay, so if we actually try to find two triangles, you see that we'd only get one. Okay, another option here, you see you're given A, B, alpha, and so same way we need to start by trying to find beta 1. So we're going to say the sine of 60 over 16, sine of alpha over A, equals the sine of beta 1 over B. And if we solve that, so you do your cross multiplication, you take the inverse sine, you're going to get a beta value of 77 degrees. And then we do the same thing to try to find your gamma 1. So 180 minus 60 minus 77. Remember, all three angles of a triangle should add up to 180. That's going to give us 43 degrees. And then we can find C1 by saying sine of 60 over 16 equals the sine of 43 over C sub 1. Follow your order of operations, solve your equation. So you're going to need to do cross multiplication, then divide. You'll get C sub 1 is 12.6. Again, makes sense. Biggest angle, opposite biggest side, middle, middle, and smallest, smallest. So we can find find B2 by, remember, beta 2, equals 180 minus beta 1. Okay, if we solve that, we're going to get 103 degrees for beta 1. And then to get gamma 2, we need to take 180 minus alpha minus beta 2. And if we get that, you see we have 17 degrees, which makes sense. It's a positive angle, so that tells me right there, I know that there are going to be two triangles here. And the last thing we need to find then is C2, which we're going to use law of sines again. So sine of 60 over 16 equals now the sine of 17 over C2. And make sure you're using 17 because we need to find the corresponding side for that. And if we do it, we get that C2 is 5.4. So here are two triangles, and you see all your values for that. An example of one that will give us 0 triangles. Again, we have A, we have alpha, we have B, so we can start by finding beta. So we're going to say the sine of 18 over 9.3 is going to equal to the sine of beta 1 over 41. Okay, now one thing, I look at this and I see that 41 is a lot bigger than 9.3, so I'm thinking beta 1, if it exists, it has to be a lot bigger than 18. So if I solve that, I'm going to get that the sine of beta 1, multiply both sides by 41, is 1.36. Remember, we can never have a value here that is more than 1 or less than negative 1. Think about your graph. We oscillated up and down between 1 and negative 1. So any value that's more than 1 or less than negative 1 won't work. And in fact, if you tried to take sine inverse of 1.36, you would get that there is no solution. And therefore, a figure that has these given characteristics does not exist. And so you would have 0 triangles. You could say 0 triangles or no solution. Okay, so we talked about 3 different options there. We could have 0 triangles, 1 triangle, or 2 triangles. It's really pretty short amount of work if you have 0 triangles. Otherwise, you just want to actually test for both triangles. If you get a sine value that doesn't work or a negative angle, then you know it has to be either 0 or 2 triangles. All right, see you next time.